Hello everyone, we are starting with the topic second law of thermodynamics. The contents of these topics are limitations of first law, features of second law, introduction to thermal energy reservoir, statements of second law, heat engine, refrigerator and heat pump, then equivalence of two statements, perpetual motion machine of first and second kind, reversible and irreversible process and Carnot cycle or Carnot engine. So, what are the limitations? Now we are discussing the what are the limitations of first law of thermodynamics. First law of thermodynamics, as we have studied that during any cyclic process, the net work transfer is always directly proportional to heat transfer, and therefore work and heat are mutually convertible one into another. A certain energy balance must be held when system undergoes a process. But the first law of thermodynamics does not impose any restriction on the direction in which process is feasible. As far as the first law is concerned, the heat transfer to the heat engine could be converted to useful work, but we all know it is not possible to convert net heat into work because no machines has been made which gives the 100% output. Further, it is our experience that if a glass of hot milk is left in the room, if the glass of hot milk is left in the room, it eventually cools off after a certain period. The amount of heat rejected by the milk is gained by the room air and the quantity of heat is balanced. Now, let us consider the reverse of the process, that is, getting the cold milk hotter as the result of heat transfer from the room air. But such a process is impossible in nature. Another example. So, in this diagram, it is shown that what is possible and what is impossible. Next, the second limitation of first law is that it does not ensure whether the process is feasible or not. So, diagram says that a paddle wheel is operated by falling weight. As it rotates, it steers a fluid within an insulated container. This container consists of a fluid in the form of gas. The decrease in potential energy of weight is equal to increasing thermal energy of the fluid mass. However, the reverse the process, rising the weight by decreasing internal energy of the fluid, does not occur in nature. So this wood diagram shows that it is not possible, or first law does not say told that if whether the process is possible in two ways or not. Next, then third limitation is this law does not differentiate heat and work. It concerns with the quantity of energy and the transformation of energy from one form to another with no regard to its quality. It means that the second law of thermodynamics takes into account the direction of the process as well as quality of energy, and it states that in any process, high grade energy can only be converted into the low grade of energy. The energy cannot be upgraded by its own. So, high grade energy is nothing but the sharp work, low grade energy is nothing but the heat. So, high grade energy can be converted into useful work completely, but it is impossible to convert low grade of energy into high grade of energy completely. So this one is the third limitation of the first law. Now, to overcome all these limitations, second law of thermodynamics exists. So these are some features of the second law of thermodynamics. First is to identify the direction of the process. Second is the establishing the condition for equilibrium. Third one, it also asserts that energy has the quality as well as quantity, as we discussed in the previous slide. And the last one, it is also used to determining the theoretical limits of performance of heat engines and refrigerators. Now we move forward. Introduction of thermal energy reservoir. This one is the new term you are going to learn in this subject, in this topic, that is thermal energy reservoir. It is nothing but the hypothetical body with infinite heat, that is thermal capacity. It is having the infinite heat capacity. What does it mean? A thermal reservoir can supply or absorb finite amount of heat without undergoing any change in its temperature is called as a thermal energy reservoir. So, for example, it is ocean, river, or atmosphere. Means if we withdraw one bucket of water from the river or ocean, so it does not affect its overall temperature. You can withdraw more number of buckets or more number of water from the ocean or river, so it does not affect the overall temperature. Means these bodies are the thermal energy reservoir bodies that supplies energy that supplies energy in the form of heat is called as a source, and the thermal energy reservoir that absorbs energy in the form of heat is called as sink. Moving towards the next slide. Now we comes to the statement of second law of thermodynamics. The second law of thermodynamics consists of the two statements, that is Kelvin Planck statement and another one is Clausius statement. So with reference to that, we move further on the statements of the second law of thermodynamics.